Hey everybody, it's Mr. Brew from Infinity the Math Institute with lesson 3 of our series of Introduction to Higher Level Mathematics. I've really enjoyed teaching you guys these classes. I hope you're enjoying watching them. And today's lesson is going to be about decimals. Super important, super necessary, and easy to understand. All it is cutting something up into 10 pieces, right? If you want to multiply something by 10, you move the decimal over once. 3 times 10 is 30. 40 times 10 is 400. 123 times 10 is 1,230. And if you divide something by 10, you take away a decimal place. 10 divided by 10, 1. 20 divided by 10, 2. 100 divided by 10, 10. What happens is if it doesn't end in a 0, that decimal falls on the other side of the decimal. So 123 divided by 10 is 12.3. And what does that 0.3 mean? It means 3/10. We're cutting 1 up into 10 pieces. But we're going to get into all that. First thing we're going to do, before we review decimals, so that way you'll always understand money. You'll always understand anything having to do with the decimal. From now on, tax rate, yada, 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 how to add, subtract, multiply, divide. We're going to do all that. But first, we're going to take your quiz. I know you thought you were going to get away without your quiz today, but alas, we will have our squares and cubes quiz every day along with vocabulary. So really quick, make sure you have your paper numbered 1 through 10. Pause the video if you need to, and we're going to get started right now. Those of you joining us for multiple times know the way this works, but I will simply give you less than 5 seconds to answer each question, because these answers must be a reflex. You got to know them inside and out. 8 cubed, 13 squared, 5 cubed, 11 squared, 7 cubed, 15 squared, 9 cubed, 9 squared, 6 cubed, 14 squared. Pencils down. And now obviously you're going to have to check your work. You should be getting a 9 out of 10, 9 or a 10 on all of these quizzes. The correct answers were 512, 169, 125, 121, 343, 225, 729, 81, 216, and 196. Also, now's your vocabulary test. I don't think you can write in 5 seconds all of the definitions. So when I say the word, I want you to pause the video, tell yourself what the definition is, unpause the video, and I'll repeat exactly what you just said to yourself. Are you ready? Integer. Whole numbers and their opposite. Absolute value. Distance from 0. Polarity. Positive or negative. Fundamental theorem of arithmetic. Every whole number greater than 1 is a unique product of primes. Subtraction. Adding the opposite. Division. Multiplying by the reciprocal. Identity. An operation that does not change the value of a quantity or a number. Inverse. An operation that brings you back to the identity. Commutative property of addition. A plus B equals B plus A. Order doesn't matter. And finally, the associative property of multiplication. A times B times C equals A times B times C. The grouping doesn't matter. I'm hoping you guys are really working on these vocabulary words, working on your squares and cubes. Of course, we need to make sure our multiplication is down perfect, so that way we can move on to these higher level lessons. So, without further ado, let's get into our lesson about decimals. Just a quick reminder, everybody, you can find all our previous lessons on vocabulary, the prime factorization in integers, the coordinate plane operations on our YouTube channel. All of them are there, and we did our best to label them in order. And again, if you have any questions, visit us at tutor@themathinstitute.com, and I'll be glad to clear anything up. Also, comments, likes, shares, subscriptions, it's all good. All right, so if you remember from the first lesson, I explained how we're in a base 10 number system, which simply means we have 10 symbols to represent quantities. Once we run out of symbols, we start a new column. For example, you count 1 through 9. After we run out of symbols, we turn the 9 into a 0 and add another column. And then we could go 10, 20, 30, and when we get to 99, we run out of columns, we run out of symbols, so we add another column. So after 99 comes 100. Now this should be basically review, but when you notice this decimal point right here, that's basically our starting point, right? And the first column of numbers is known as the units place. That's just the ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the tens place. And of course you should know that this is the hundreds place. All right? Now we have commas separating every third number as we move on, because this is the units place for thousands. This is the unit place for millions. This is the unit place for billions. Consequently, this is the tens place for thousands, tens place for millions, tens place for billions, hundreds place for thousands, hundreds place for millions, hundred place for billions. So, I mean, if you wanted to say this number without the decimal point, it would be 123 billion, 456 million, 789,012. That's how you say these numbers, all right? Everything's broken up into their own little category. After billions, we have trillions, quadrillions, so on and so forth. Now let's get into what we're here to talk about, the decimals. First of all, notice there's no commas on the decimals, okay? You're just gonna have to count places. I know, sounds like fun. This would be the tenths place. Tenths. All of these end with the THS. All right, so the units is the middle point. We have tens and tenths. 2 spots over from the units is the hundreds. 2 spots over from the units is the hundredths. And so on and so forth. We have the thousandths, the 10,000ths, the 100,000ths, and the millionths. And you're just going to have to understand how to accentuate and vocalize what place you're speaking about. Whether it's the 100 millions, or the millionths, or the 10,000ths, or the thousandths. Whoa, I messed up. The 10,000s. The thousandths would be right here. I know, it could be a little confusing, but it's really quite simple. Start with the units and move that way. Start with the units and move that way. So, what are decimals? They're simply fractions with a denominator of a power of 10. So, like we learned over here, this would be known as 1/10. 1/10. Which could also be written as a fraction. 1/10. The tenths. This would be 23 hundredths. Also known as 23 over 100. 23 hundredths. They're all going to be a power of 10. Right? 10 to the first power is 10. 10 squared is 100. 10 cubed is 1,000. How many spots do we have? 1, 2, 3. Tenths, hundredths, thousandths. So this would be 456 thousandths. And that should be pretty clear. We're always going to have a power of 10 in the denominator. Now, if we have a number greater than 1, like 1.2, we are using the tenths place. So, this is equal to 1 2/10 or 12/10. Which is also, when we go into fractions next week, you'll understand this even better. This is actually 1 2/10. Can you figure out which one this is as an improper fraction as well as a mixed number? We're going up to the hundredths place, so that will be my denominator. It will be 345 over 100, or as a mixed number, it would be 3 45 hundredths. And that's it. That's how we start off with fractions, all right? This is 1 2/10 of another one. This is 3 45 hundredths of another one, all right? So let's get into rounding before we get into the meat and potatoes of operations. All right, so one thing that may seem like common sense, but I just want to refresh your memory, is little things. Like, for example, 5 is equal to 0.5. Or even 0.05, right? I could throw zeros in there. 0 hundreds, 0 tens, and 5 is 5, right? Same thing. It is also equal to 5.0. 5 is equal to 5.0, and 5.0 is equal to 5.00000, right? We could add zeros before or after a number as long as we're properly using a decimal point. Obviously, 5 does not equal 50, right? We just need to maintain that decimal point in order to do it. Then it works, okay? And the power of 0 will help you with some of these operations. For example, a question on your homework is, which one of these is greater? All right? Now, I hope most of your common sense kicks in to say 8.5 is greater than 8.05. But let's make it crystal clear. All right? First of all, this is 8 5/10. This is 8 5 hundredths. But when comparing numbers in more difficult situations, we want to have common denominators so we can clearly take a look at that. So what I would do to prove it is I would add a 0 here. And that changes it, because now we're going to the hundredths place and we have 50 of them. So this is 8 50 hundredths, and this is 8 5 hundredths. Therefore, you understand that the weight of the tenths place is 10 times more than the weight of the hundredths place. Sorry, had a little brain fart there, but if you're able to write it out and say so, you'll be a-okay. So 8.5 is equal to 8 5/10, or 8 50 hundredths. 8.05 is simply 8 5 hundredths. Therefore, clearly, 8.5 is greater than 8.05. On another one of your homework questions, it's give me a number between these two numbers. First of all, it's assuming that you understood our lesson on operations. All right, so obviously the negative numbers go that way, the positive numbers go that way. But also, how would you take care of solving this problem? The first thing I would do is I would make a 0 and a 0. That makes it a lot easier. So now we have -1 350 thousandths, and we have -1 340 thousandths. Right? And we can see what numbers between 340 and 350. I would say it would be -1 345 thousandths. Now that may be a little confusing because we only gave you numbers up to the hundredth spot. But you could always add zeros, you could always add decimals, you could always manipulate the numbers as much as you'd like. Therefore, -1 345 thousandths is the number that is in between the two. -1.345. That's greater than 1.3, that's less than -1.34, yet greater than -1.35. This number falls in between the two. There's a bunch of problems like that on your homework. Again, the link should be underneath in the description. One other thing that we want to review really quick before we get knee deep in decimals is rounding. All right? Rounding is simply making it an easier number to express. For example, pi. Pi is an irrational number. The decimals go on forever, and we're going to get into that in detail later. But the bottom line is you can't even possibly tell somebody the decimal representation of pi because it goes on forever. So we tend to round it. All right? Here is a rounded version of pi right here. And this has got up to the 10,000th place, but it continues. All right? I could even say so with my dot, dot, dot. Now, if I wanted to round to the units place, I look at the tenths place. If the number is 0, 1, 2, 3, or 4, I leave it alone. If the number is 5, 6, 7, 8, or 9, I round it up. So this number rounded to the units place, I look at the 1, I don't change nothing, it's simply 3. If I wanted to round to the hundredths place, the first thing I look at is at the hundredths place, where I have a 4. Then I look at the next number. Is it 0, 1, 2, 3, or 4? I leave it alone. Is it 5, 6, 7, 8, or 9? I round it up. It is 0, 1, 2, 3, or 4, so I'm going to leave it alone. So when I round to the hundredths, it's simply 3.14. If I round to the thousandths, I need to find the thousandths place. Then I look at the next number. It is not 0, 1, 2, 3, or 4, so I do not leave it alone. It is 5, 6, 7, 8, or 9, so I round it up. So in order to round pi to the thousandths place, I make this 3.142. All right, and that's just a little recap on rounding. Again, there's a couple of problems, quite a few problems in your homework packet. Give them a try, and if you have any questions, drop us a comment below. So now in the links provided below, I put all the rules for decimal operations, and I'm sorry, but you really should memorize them. Here I'm going to explain each of those rules one by one. Number one, when adding or subtracting decimals, you must line up the decimals. Just like when we do any kind of addition or subtraction, you got to line the units place in the units place, the tens place in the tens place, and so on and so forth. If you had 340 minus 25, you can't write it like that because the units place has to be lined up with the units place. It just doesn't work. And obviously your common sense should kick in and understand that. Well, the same thing goes for decimals. We need the tenths place lined up with the tenths place, the hundredths place lined up with the hundredths place, so on and so forth. Usually you just start with the decimal and work your way out, whether it's into whole numbers or it's into parts of whole numbers. Line up the decimals. So when we're adding something, all we do is line up the decimals. These are already lined up. So we have nothing to do but add. 5 plus 5 is 10, 1 plus 2 plus 7 is 10, 1 plus 1 plus 8 is 10. I bring down my decimal. 1 plus 2 plus 7 is 10, and 1 plus 1 plus 2 is 4. So the answer is simply 40. You do not have to answer it like that. All right, all we need to know is that the answer is 40. Obviously, if we did have decimals, we would have to write it out, but any zeros after the last decimal place are unnecessary. But the 0 in the units place is very necessary. So let's take a look at another one. This is a subtraction problem. Now, first of all, we don't even have a decimal on the top. So what do we have to do? We have to understand that the decimal comes after the units place. All right? Number two, I have my tenths place lined up with my hundredths place, and my decimal is not lined up with my decimal. So I'm going to have to rewrite the problem. I'm going to write 100 point, and I'm going to just throw 4 zeros in there. 0, 0, 0, 0. That way I have every single units place or place value accounted for. I'm going to line up my decimal below it. Before the decimal is 96, and after the decimal is 8695. Now that my decimals are lined up, it's just a simple subtraction problem. We have to do a bunch of borrowing, which I'm sure you all know how to do. 0, 10, 9, 9, 9, 9, 9, And now it's just an easy subtraction problem that you were able to do in elementary school. 9 minus 5 is 4, 9 minus 9 is 0, 3, 1. Bring the decimal down. 9 minus 6 is 3, and 10 minus 9 is 1. So the final answer is 13.1304, or 13 and 1,304 10,000ths. But even though it's not maybe as mathematically elegant as I like to be, I always tend to just say 13.1304. And you could always check your answer like you did in elementary school. Is 13.1304 plus 96.8695 equal to 100? My money is on it does. All right, let's get into multiplication and division. All right, now multiplying decimals is really quite easy. I'm going to try to show you why, but the first thing I'm going to do is just tell you the rule. You need to write it down or look it up in the link below. When multiplying decimals, multiply as if they're whole numbers. Ignore the decimals. Then when you get your final answer, count how many decimal places were in the question, in the two factors, and move the decimal point that same amount of spaces. Let me show you some easy examples. For example, we know that 3 times 3 is 9. Easy enough, right? Well, 3 times 0.3, I multiply as if they're whole numbers. 3 times 3 is 9. And then I count how many decimal places were in the question. I have 1 total. So I'm going to move the decimal place over 1 spot. So my answer is 0.9. If I was to have 0.3 times 0.3, well, again, we multiply as if they're whole numbers. 3 times 3 is 9. Now, how many times do I have to move the decimal place? 1, 2. So I move it over 1, 2. And obviously, I'm missing a 0. So the answer is 0.09. All right, and we could go on and on and on. Right? 0.003 times 0.03 is equal to, now I multiply as if they're whole numbers. 3 times 3 is 9. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the answer is 0.00009, or 900 thousandths. Okay? Very simple. Multiply as if it's a whole number, count the decimals in the factors, and apply the same number of decimals to the product. One other trick I want to show you before we move on is when we're multiplying by tens, we know to add just a 0. Well, if we're multiplying by 20, we can multiply by 2 and add a 0. For example, what's 42 times 10? I can do it the long way, 0, 0, and then 2, 4 is equal to 420, right? But us mathematicians, we have a shortcut for this. Instead of doing that, we leave the zeros hang off the end. Times 10. We just bring the 0 down, and then 1 times 42 is 42, giving us 420. So what if I was to do 42 times 20? I don't want to write it like this. That's just going to be unnecessary work, and it's going to lead to a messier piece of paper. And it's going to leave you more susceptible to making mistakes. So I'm going to times it by 20 by leaving the 0 hang off to the side. Then I simply bring down the 0. 2 times 2 is 4. 2 times 4 is 8. And my answer is 840. What's beautiful is it doesn't even matter. I could do 42 times 2,000. Leave the zeros hang off the side. 42 times 2 is 84. So it's 84,000. It's just a little trick that we're going to be able to use when we're multiplying by 20 in the next step. So in this question, we have 20 times 95 thousandths. All right, so how are we going to write that? Well, I have more digits in this one, so I'm going to write that on the top. I'm going to write 0.095 And then I'm not going to write times 20. I'm going to leave the 0 hang off. Now I multiply as if they're whole numbers. Bring the 0 down. 5 times 2 is 10. 9 times 2 is 18, plus 1 is 19. 2 times 0 is 0, plus 1 is 1. 1900. Beautiful. Now, how many decimal spots do I have in the factors? I don't have any here. Remember, this is 0.00, right? I have 1, 2, 3 here. So I'm going to move the decimal place over 1, 2, 3 times. So my answer is 1.9. Should be no problem. Here's a slightly more difficult problem, just to make sure you guys are all on the same page. I'm going to write this number since it has more digits on the top. You don't have to. All right, and what do I do first? That's right, I multiply them as if they're whole numbers. Ignore the decimal. So I'm going to have 5, 1, 7, and then 15, 4, and 21. I add them up, and I get 22,165, which is what 31 times 715 is. But that wasn't the question. The question, the factors contained 1, 2, 3 decimal places. So I move it over 1, 2, 3 decimal places. And I get 22 and 165 thousandths, or like I like to say, 22.165. Multiplying, super easy. Multiply as if they're whole numbers, count the decimals in the question, apply them to the answer. Now let's get into division. I would love to revisit this division lesson when you know more about fractions next week, but it's going to be really easy to understand. Check it out. For example, when I have 4,563 divided by 9, right? We all know how to do that, right? We just do 9 into 4563, which is equal to 5, no remainder, 9 doesn't go into 6, 9 goes into 63 7 times. It's 507. That should be your quick review on long division. But my question is, what if we have 4,563 divided by 0.9? That changes the game a little bit. Now, first of all, you should recognize that this is the same thing as saying 4563 divided by 0.9. It's just another way to say it. Another way to say it, the third and final way, would be how many times does 0.9 go into 4563? And here's the secret, all right? First of all, I can multiply this by 1 in the form of 10 over 10, which would give me 45630 over 9. These are the same things, which leads to our division rule. You got to make the denominator a whole number by moving the decimal. However many times you move the decimal in the denominator, you must do the same to the numerator. Like here, we moved it over once, so we had to move it over once in the numerator, which gave me that 0. So right now, what I can do is I can move this over once, but I also have to take my decimal point that's here and move it over once. So now my decimal is actually here. And now it's just a simple division problem. Move my decimal up, keep it where it is. 9 goes into 45. Again, we already figured this out. 5 times 0, 7. And now how many times does 9 go into 0? 0. So the answer is 5,070. All right, let's try one more quick problem. On this one, this is the denominator. So I'm going to have to move my decimal 1, 2, 3 times. Anything I do, the number I move it in the denominator, I must also do to the numerator. 1, 2, 3. So this turns into a new question. This is asking me how many times does 21 go into 77769,600. And the decimal point will go there, and the decimal point will remain there in the answer. Really quick, just a quick review for those of you who are having trouble with long division. Anytime you have a divisor that you're not totally comfortable with, I made you memorize your multiplication from 1 through 12. I didn't make you memorize your 21s. But what I would do is I would jot down the multiples. 21, 42, 63, 84, 105, 6, 7, 8, 9, and then this will be 126, 147, 168, and 189. 21 times 1, 2, 3, 4, 5, 6, 7, 8, and 9. And that's going to be all the hard work that I have to do. Now it's an easy problem. How many times does 21 go into 7? 0. 21 into 77? 3 times. 3 times 21 is 63. So I'm left with 14. Bring down the 7. 21 goes into 147 exactly. 1, 2, 3, 4, 5, 6, 7 times with no remainder. 21 goes into 6 0 times. 21 goes into 69 3 times. 3 times 21 is 63. Got a 6. Bring down the 6. 21 goes into 66 again 3 times, which is 63. And I'm left with 3 0. By bringing down the 0, 21 goes into 30 1 time. 21 leaves me with 90. 21 goes into 94 times, which is 84, giving me a remainder of 6. So it will keep going on and on, but nonetheless, if I wanted to round to the nearest whole number, 21 goes into 60 about 2 times. So this would be my answer rounded to the units place. Again, there's a lot of practice problems in your homework. Please give them a try. Take pictures if you're not coming up with the right answers. I have the answers at the back of the homework. There's plenty of practice problems, including some word problems, so you can start getting used to decimal points in real life, whether you're talking about temperature, money, or percentage rates. Either way, you're gonna come across decimals all the time. I am not 6 foot tall, right? We have inches, all right? Decimals are just breaking up whole numbers into smaller pieces, so that way you're able to get an exact measurement. So practice those problems. I'm looking forward to seeing how you do. And don't forget, we're gonna have our vocab quiz and our squares and cubes quiz next week. Thanks for tuning in. Visit themathinstitute.com or visit us on any of our social media platforms, Instagram, YouTube, Facebook. We love having you, we love the support, and we love our kids. They're doing some really amazing things, and I hope you're doing some amazing things at home as well. Have a good one.